Thank you, guys. So in this talk, we are going to look at how we can actually abuse Logic App, how we can leverage multiple other services within Logic App, like use storage accounts and stuff to abuse Logic App. So let's start with an intro. Hi, everyone. My name is Chirag Savla. I work at White Knight Labs as a senior cloud security engineer. My interest areas lies into Azure, Active Directory, anything that is offensive, breaking into networks and stuff. I have created a couple of open source tools also like Process Injection Toolkit, Calidus, which actually uses Microsoft Graph APIs for doing C2 communication and stuff, but that is again a POC tools, cannot be used in your prod engagements. Being a trainer, speaker at multiple international conferences like Black Hat, this year also at Black Hat US, at Arsenal, we are presenting a tool and have been training multiple people across multiple conferences.
So hi everyone, my name is Ronak Parmar, aka Trouble One. Even I work as a senior cloud security engineer at White Knight Labs. I've been an OSW certified, and that's my first ever certification I have done in my career. I'm mainly into AppSec and CloudSec, working highly on Azure and AWS. A couple of tools are already published by myself, but this one, the Vajra, is the most intense tool, which is a complete cloud Azure pen testing tool, which we use a lot during Azure pen test, and we have like a private version of this tool. Even I have been a speaker at multiple conferences like Black Hat, DEF CON, NullCon, RootCon, and now at NorthSec as well. I've been also a trainer at NorthSec. I delivered my first ever training on CI/CD pipeline hacking course. Before coming on in this industry, I used to be a DJ and a music producer. So yeah, that was all about me. So let's first understand what is the Logic App within the Azure. So Logic App is a service which allows you to automate your certain workflows without writing any codes or almost zero code. So how you do that? So there is a visual designer component which is within your Logic Apps, which can be used to just drag and drop certain tasks and just align them in the way that you want, and that's it. Your whole workflow will get set up. And it can be integrated with your third-party applications or maybe your Azure's other resources like your virtual machines, storage accounts, file shares, PowerPoint, Outlooks, or anything. So if you ask a Logic App, like, what's your plan, bro? So he will respond to you like, OK, I have two plans. I have a consumption plan, and I got a standard plan. So if you go with the consumption plan, it's just a one plan. It means that you can only run one workflow at a time, and nothing else. But if you choose for a standard plan, it means you can run multiple workflows, and it's kind of a big environment. Like there are a lot of things also runs in the background, which we will talk in later slides. So in a workflow, there are two main core ingredients which is used, which makes the workflow run. So one is a trigger, which says like, hey, start now. And this start now is like a kickstart, which can be done in different ways. Maybe an HTTP URL, or maybe just run it, or maybe some intervals can be created. And the action is the one who does the action which you want. So push a button, save the world, or just start a workflow. So in workflow, you get an HTTP URL, which can be used to run those certain workflows. And each workflow comes up with a unique URL, which is not accessible from the JSON view of the workflows. But yeah, there are certain permissions which is required to access those URLs. So there is no rocket science to execute those webhooks. You just need a webhook, a post request, and some data. That's it. Just hit it and just save the world. So it's a very great for your automations, or maybe a place where you can just start your panic button. Set it and forget it. So workflows also have an options for intervals, as I mentioned. So you just don't need to again run those workflows. Just set some intervals, and based on those intervals, it will just keep running that. And behind those scenes, it's using a standard logic plan, which is used for all your heavy lifting stuff, or your major workflow stuffs. And yeah, it uses function app ideally as a friend to run those workflows. So your Logic Apps can be integrated with a lot of different services, not just Azure services, but also your Twitter, your LinkedIn, your Dropbox, your whatever like things you need to integrate with that, those can be integrated, those can be aligned. And yeah, it's a boat. So if something goes wrong, you can blame the boat and not the human who actually configured those workflows. So as I talked about the Logic App Designer, it's all about just drag and drop and pray it works. So it almost needs no code. Ideally, there are some options where you can run some codes. But yeah, for the designing, you don't really need some codes. You just need to have some parameters align themselves properly, where it should go, what it should done, and that's it. And there are more than 100 plus pre-built connectors, and there are a lot of third-party connectors which can be used, integrated, or maybe abused if some permissions are found or some users has been hijacked. So this is how your designer would look like, where you have this HTTP request as your trigger, which gets executed, and once executed as a post request, in these actions we have a list of bulbs of your storage account which can be listed. But in real world, it can be a very big workflow. It can be used in a very different ways. Then, if you are a hardcore coder, you won't trust this designer, right? So in those cases, there is something called as code view, which gives you a JSON object of your visual designer, which looks something like this. If you observe correctly, there is no webhook URL found in here, because by default, you don't get the URL directly in the JSON object. You have to run a different API call to get those URLs. So how can this be used without having any human tiers? So assuming there is some order platform, some inventory or some shopping cart you have, in those cases, you can have these actions like, in first action, send the order confirmation to your email or via email to customer. So you can integrate the Outlook and have some parameters coming along with your webhook URL. In second, you just notify your warehouse team via Teams, via Slack, via Discord, or whatever channels you guys are using. Then update the inventory in the database. You can integrate your Cosmos DB, your SQL database, whatever database you have, and maybe update the Excel files, and yeah, you can create the billing stuff as well. So that was just an idle use case of the workflows. And one URL to rule your workflow. So if you observe the HTTP URL, that's the URL. If it's exposed, anyone in the world can just hit a post request, and it can run those workflows. So what if you gain a Logic App contributor? So if you have a Logic App contributor permissions, it's almost over, like, because you have full control over all the workflows which is created within the Logic Apps. You can abuse some managed identity stuff. You can hijack the API connections. Now, those API connections are basically your third-party integrations, which is your Outlook, your any other team channels, your some other services. So if you have permissions to access those and you don't have permissions to access Logic App, so in those cases, you can create a new Logic App, and in your code view, you can just integrate that API connection, and that can be abused. So in standard plan, what happens is whenever you create a new Logic App with a standard plan, there are certain services also gets created, which is an app service, a storage account, and your function app. So function app is not created, but your Logic App can work as a function app as well. So obviously, yeah, it supports multiple workflows, and it's more like a scalability product that you can use. So consumption plan, as mentioned, it just run one workflow at a time. No services created, no additional functions and or storage accounts has been created, and automatically scales with demand. So you have to run again, and based on your executions, the prices would also be determined. So I talked about managed identity. So what it is? So basically, let's say you have a Logic App and you need to access certain resources. So what do? Are you going to just hardcode some credentials within your Logic App? No. You will use the managed identity, which says that, okay, Logic App, now you have the permissions to access this specific resource without any credentials. So in that case, you will grant the metadata API calls to get the access tokens, and you can access those resources. So any compute services like app service, function apps, virtual machines, whatever the compute service is available, which can have this managed identity enabled, and you can access those resources which are available within your Azure or within your intra-ID, for example, Key Vault, storage account, or maybe your intra-ID users, groups, applications, and all those stuffs. So why it matters? Because it doesn't store any kind of secrets, any kinds of sensitive information, just a single API call, and that's it, you have the token itself. Oops. Yeah, okay, I think, okay. So if you have a contributor access, you have a free pass to steal those tokens. So what you can do is just start up a new a new workflow in that you can just execute some HTTP calls, and within the authentication of the HTTP, you can mention that I need this HTTP to go with my managed identity of certain resource, maybe like your management.azure.com or maybe your graph.microsoft.com, and you have a free pass to steal those passes or tokens. So in this case, if you observe, we created this HTTP request, and within the authentication type, we have managed identity, which is a system assigned managed identity, which means I'm asking my logic app to create an HTTP request by utilizing the managed identity to my server. So what would happen is in my attacker server, in the authorization header, I will be getting those tokens directly. So this was the case when Logic App didn't have these options to execute system commands. Now, although some operations has been added through which you can just run the C# code or maybe Python code, but yeah, back to old days, we didn't have those options. So we have this only option to just run the HTTP call, and that's it. So raw, basic, managed. So if you observe again the HTTP authentication types, we have a lot of different types. For example, basic auth, client certificates. Maybe if you have a service principal, so you can just use the certificate, or maybe raw, or maybe the managed identity. So here in the previous slide, we abused the managed identity feature. Why would you use some vault if you just can run the Control-C button to just paste some service principal credentials? So this was the scenario when me and Chirag were doing a pen test almost 1 year ago, and we found a Logic app had a service principal credentials exactly same way, doing some graph API calls just for read, but had some additional permissions through which a whole attack part was something like hijacking the complete infrastructure of the Azure, even the on-prem systems, the Intunes, the DevOps, and becoming the global admin over the intra-ID, and as well as on the AED Connect server as well. So yeah. And as I said, whenever you create a standard plan, a storage account also gets created. And what happens is all those workflows get synced up with your file shares. So anyone having access, just a read access over the storage account, can list out or can read those workflows directly. So yeah, if it's something hard-coded, a reader from storage account can hijack those credentials as well. So in Logic App, there is an option where you can upload some assemblies. Here you can see we have this auth library.exe. So they've tried to upload some exe, but we are still going to crack it open. Why? Because storage account has all those assembly files stored within your storage account as well. So again, any user having a storage reader role can actually download those exe files directly from the file shares itself. So yeah, I would transfer this to Chirag, and we have more sarcastic slides next. Yeah.
Thank you, Ronak. So now we saw that we have access to a storage account, right? What if like Logic App is connected to the storage account? What if we have access to a storage account? Probably like read-write access. On the read access, we saw some things like you can extract or dump workflows. You can get assembly files which could have some sensitive information. If you look at one of the previous slide, we see that it is like .NET assemblies, right? Which means ideally it can be reversed easily, right? Currently, standard Logic App only supports .NET assemblies or client SDKs that are built in .NET Framework or .NET. And since it can be reversed, and there are ways by which you can actually find hard-coded credentials in this library files. These are like dependency files that have been used within Logic App, because now Logic App has a feature where you can run inline codes. And now the codes can be executed in like Node.js, C#, PowerShell. So you have like entire power of executing like system commands also, and probably if something like this are used as a reader privilege on a storage account, probably you can compromise a lot of more stuff. So let's go through some of the cool attack paths that we have found while exploring a Logic App. previous year, when we actually blogged about one of the logic app use case of how actually standard logic app has been used, right? That time Azure used to reveal that, okay, we use Node.js stack, and that was directly in the configuration tab. But when we were exploring this, after some time, probably Microsoft modified that entire environment. And now what we see is, we don't see a stack, but now when we actually look at the environment variables, we see function worker runtime set as .NET, which means now all the logic app workflows, that is basically a standard logic app workflows, run in a .NET, as a backend has a .NET pre-built, pre-installed. But it does not end here. As we have already looked at how logic apps standard plan uses function app, we actually, when you try to browse this logic app URL, you'll see this as a default page, right? Which actually gives us an information that, boss, we are using function app, but when you actually go and check the function app tab inside the portal, you'll see nothing, okay? Which means, but logic app is using function app, that's how it is, right? So since you can, or standard logic app uses function app, why don't treat those storage accounts associated with it as function app? So as an attacker, you can actually create folders, upload your execution scripts. That is basically, you can say in this run.csx, which is basically a runtime file to execute .NET code with a binding file function.json. If you do that, you can deploy any code. One of the example here is, this is my .NET code, which is a default .NET code that I can upload, right? I also have a default binding file that I can upload, right? But now we saw that the function runtime is .NET. What if I tell you you can also run Node.js? There is .NET, the built-in function runtime is going to execute .NET. But if you upload a .NET function, which is like a dummy function, and at the same time, you create another folder and upload a malicious Node.js file, which can execute system commands, ideally, it would allow you to execute Node.js commands or Node.js function, but not the .NET function. Okay? I don't know the reason, but that's how logic app works in the backend, right? Even if you upload PowerShell functions, PS files, it will allow you to execute system commands, somewhat like this. You can see I have a folder named .NET, and my .NET code, that is a dummy logic app or function app code, which is present there. But still, when I created a new folder named Node.js func, and then I added a code which can allow me to execute system command, it does that, right? Once you have access to system command, what all things you can do? You remember we saw some few slides back, we saw something that was like your connection string to a storage account. Like if I have to go show you this, if you look at this, the Azure Web Job Storage, how do you get an access to this? This is basically a configuration that is present inside your environment variable of a logic app. But now if you have a command injection on that logic app, which is in backend running a function app, you can simply list the environment variables. And if you list the environment variables, you get the storage account connection string, which is like giving you full control on the storage account, read, write, access entirely on the storage account, be it a blob storage, file share, anything, right? But there are a few interesting things that are configured or present inside the storage account. We saw some workflow files, right? What about configuration files? So now if we look at this, we can see there's some configuration file inside host.json. What is that? Basically a master key. But we don't need to worry, it is encrypted, right? But what if you have command injection? I told you you can list environment variables, right? In environment variables, you can find some decryption keys. And then there was a good research done by NetSpy team, published at DEF CON, FungoPop. This app can allow you to decrypt this master key offline, which means you just need two things, encrypted master key, and probably one of those keys which are used for encryption purpose. And then you can decrypt it offline, use that master key for lifetime. There is no way to modify the master key or rotate the master key from the logic app, console, portal, or anywhere. The only thing that is present, that is in the storage account, probably you re-encrypt that key with the encryption key and replace that. That's the only option at the moment. Because you don't have an option on the portal, that means probably the users don't know. Once you have an access to a master key, for the lifetime you own that particular logic app, you can do whatever you want, whenever you want. Why to encrypt? Why to decrypt? Why to crack those credentials? If you have write access, there is a simple flag that you can modify that is set as encrypted, true, and if you modify it to false, ideally, that encrypted master key becomes your unencrypted value, which means you can use the exact same encryption key to perform any actions on the function app. Now, since in the backend, Logic App uses standard workflows, and since standard workflow uses function app, all the admin APIs that can be used with master key, you can use this. Again, which means that once you have the master key, you have admin access on that particular logic app, on all the functions that you can build on top of that logic app. Maybe stealing credentials. Maybe if in future, if they integrate this logic app with some or the other third-party services, maybe payment gateways, right? Which is very common, right? Because they're building automation workflows. They want certain things to be automated. You could gain access to all those services. What if the managed identity of the logic app has access to 365s or Microsoft 365, like probably SharePoint, Teams, boom, you own everything, right? There have been cases that we have found wherein Logic App is used for automating a lot of tasks, like giving application admin permissions to make sure that they look at if are there any application secrets that are going to be expired. If yes, probably send an email notification to all the admins, right? And for that case, they use managed identities. Sometimes they use API connections also. But when they use managed identity, they grant high privileges, which indeed allows you to control a lot of other services, right? But that's not enough, right? Microsoft has created a lot more additional shortcuts which can help us to abuse Logic App, right? There's something known as SCM portal, which is a portal designed across all the services that uses app service in backend. Again, since we are using Logic App standard plan, in backend it spins up an app service plan, right? And as soon as it spins up app service plan, there is a SCM portal that is attached to it. What is a SCM portal? It's like an admin portal which allows you to manage the entire environment. You can look at the codes, you can execute commands, you can do whatever you want. How do you gain access to it, right? What if you have read privileges on something? So now, if you have read privileges, or if you own any user with some built-in roles, like your website contributor, your owner privileges, or a contributor user, those built-in rules have two permissions. One, Microsoft.web/site/publish/action. This is the permission that is actually needed to authenticate and gain access to the SCM portal of the app service, your logic apps, your function apps. Now, if you don't want, or if you don't have that specific permission, but if you have another permission that is like publish XML/action, it allows you to download basic auth credits. In today's world, we still use basic auth. Anyone who uses basic auth for applications, for authentication, Microsoft does that. But there is a catch here. When you actually try to deploy this from portal, by default, it is marked as disabled. Do developers use portal? I don't think so. They are very much used to use Visual Studio Code, Visual Studio, right, for deploying, for doing all their coding and stuff. If they're using Visual Studio Code, actually they need SCM portal because Visual Studio actually uses zip deployment method to upload all the code, all the deployment, be it a function app, be it a app service, or be it logic apps. Now the catch is, if they're using CUDA service, they need basic auth credentials. And that's where SCM service or SCM portal could be enabled. So now, if you're looking at the portal, you have an option, get published profile. So if you have privileges, dump that. That's how you find credential, right? Simply to authenticate to that particular SCM portal, go to that specific URL/basic auth, and you would gain access to SCM portal. It might be very easy, right? It's just a management software. How many of you know what all powers management software could give you, right? It is not just like a shell, but it gives you power to execute commands also. You see those debug consoles? You get a list of all the environment variables, all the connection strings, all the app settings that are configured on your logic app. And at the back end, a lot of developers use these configurations to store database connection strings and multiple other secrets. Maybe connection strings for emails, credentials for emails and stuff. But Do you really want to use that when you have root shell as RC, right? So kudo engine gives you an option, gives you a privilege to execute command directly, and that too on PowerShell or CMD, depending on the backend environments that you're using. But we know that Logic App by default deploys on a Windows machine, which means you have complete PowerShell access. You don't need command execution on a function app, command execution on a Logic App, but if you have access to this, you can still do that. It's interesting, right? Now, what if I tell you that you want to pivot from cloud to on-prem, right? But you don't want to be felt like, okay, I'm doing something wrong, right? I want to fly under the radar. What about, or how about using some Microsoft default services, right? If you're using VPN, right, it's very easy to communicate, very easy to connect. Similarly, Microsoft has something known as hybrid connection managers, right? Which actually allows you to connect all your function apps, app services, or logic apps with your on-prem services. That means that if you have any services that are hosted on-prem, machines which are running probably some internal API, internal database servers, or anything like that, you can use this hybrid connection manager, which can allow you to connect from cloud to your on-prem machines, which means now your automation workflow can perform some updates in the database server that is hosted on-prem. It's so cool, right? But that is not enough. When you have connectivity, why don't we abuse it? When we see hybrid connections, if you look at this particular diagram, this is how the environment is built, right? That means that there is a bridge which is actually in backend using Azure Relay, right? Which means now you install a hybrid connection manager on an on-prem machine, and if that machine is not protected, if that machine firewall is not well managed, you can ideally use that to move laterally across other machines, other systems. This is exactly one of the attack paths which we had actually found in function app, logic apps, and it can also be used like in app services. You can see one of the attack paths where an attacker has managed to gain access, probably on the logic app, not a contributor, but a custom privilege which allows them to access the SCM portal. Right? Now, since you have access to the SCM portal, you can actually access and execute PowerShell commands, which indeed gives you the capabilities of leveraging all the configuration that is present inside the Logic app. That means, again, if you have hybrid connections, use that, authenticate to that particular machine, depending on the credentials. So if you look at in this diagram, there is a key vault that is associated with it that can actually have credentials that is like admin credentials to gain access on the machine. Why a developer would store admin credentials? What if I tell you Logic Apps can be used to manage your Windows machines, Linux machines, right? So you can also execute PS remoting command. Isn't it funny, right? You can connect your hybrid connections on a machine where you can, the hybrid connection can be configured to execute or gain access on any remote management protocols like PS remoting, WMA, and stuff. Now, if you have access to the SCM portal, and if you know hybrid connections have been used, boom, right? Your workflow is something that is going to help us to move laterally and execute any command on those machines using PS remoting commands, and you can see simple command execution. This could also allow you to move laterally, gain access to other machines. In reality, we have found this type of attack vectors from function app. We blogged about this last year, where we actually managed to gain access to another server, like gaining admin credentials, moving laterally within on-prem network, gaining access to AD Connect machine, and then escalating our privileges to global admin, right? Easy attack path, easy things that can be converted into multiple opportunities to move laterally, find hidden secrets, probably move on-prem, and then probably if you find some credentials, some more useful information that could again allow you to pivot from on-prem to cloud, right? Which can again allow you to gain GA access, that is like global admin access, right? So Logic App workflows it is not limited to like just automation, but it is like automating breaches also. If not properly prepared, not properly configured, it can lead to breaches which can like be massive in nature, because again, automations are used to connect multiple services, multiple workflows, and some could be really critical. Again, why to write exploits, right? When Azure gives you everything pre-configured, all the features, all the options that can be used to abuse Logic Apps, abuse various API connections, abuse various service connections that are integrated with Logic App. And that's what we wanted to discuss, we wanted to share. Thank you, everyone.